Welcome to qnawire.
So question 20 asks us that table 44.3 shows a particle that decays into a different particle and a photon. So we want to calculate the photon emitted in this decay if there is no energy. So this is a question that we can solve by finding the mass difference. Actually, in the table, we don't even need to find the mass difference because we are told the energy carried by each particle. So the amount of energy carried by the kinetic energy of the photon is just going to be the energy before and after the reaction. Before the reaction, this carries 11 MeV, and after 16 eV. So MeV. This is a total of 77 MeV, and this is going to be the amount of energy that is released as the kinetic energy of the photon. And then asks us to find the momentum of the photon. Well, momentum energy is related by energy equals momentum times the speed of light. So here we can find the momentum by taking the energy of the photon and divided by the speed. So the energy 77 times 10 to the 6 eV. But we want to come to SI units, so 1.6 times 10 to the negative 19 joule per electron volt over 3 times 10 to the 8 meter. So if we like this, we will 4.1 times 10 to the negative 20 kilogram meter per. So this is going to be momentum of the. This is going to be the momentum of the photon in this case. And then last we ask, is it reasonable to ignore the final momentum and kinetic energy of this particle? So I think we can ignore it. The reason is because this particle, if we look at this is a pretty large mass, and the kinetic energy of any particle can be given by the momentum square over 2m. So if we equation compared to the photon, this is going to have much less, meaning the contribution of the kinetic energy is going to be much smaller, assuming it has the same momentum as a photon, because this in the larger, this kinetic energy be too small compared to photon, which has negligible, which is very little mass. So because of that, we say it is perfectly reasonable to ignore the kinetic energy of this other particle and assume it is stationary with respect to the photon.